Next up, we have Daniel Fett, who's going to give us a presentation about OAuth and how not to use OAuth, which will include an introduction or reintroduction of how OAuth works, some of the best practices, some of the typical misconfigurations, and recommendations for how to best use OAuth in your application. Let's give a warm welcome to Daniel.
Yep, and microphone works. Okay. Yes, hello everybody. Good morning. Welcome to the OWASP, German OWASP Day. I'm very happy to be here. Thanks for the invitation. Thanks for having me. This might be a slide that might be familiar to some of you. This is essentially an update to a talk I gave at the German OWASP Day in 2019. What's there to update? Well, many OAuth implementations are still broken. We finally should fix that. But also the kind of mitigations we have today have evolved a little bit. So it's kind of important to stay up to date. Brief word about me. I'm a co-author of the OAuth Security Best Current Practice RFC ITF standard, soon to be standard. It's really in the last stages of completion. We only expect editorial changes at this point, so you can take that document, read it, and expect that not too much will change once it gets an official RFC number. I'm accordingly active in the ITF, in the OAuth working group mainly, but also in the OpenID Foundation, so internet standards in general. I've got a PhD on web protocol security, which directly led to the work that you see here. And I'm a product owner in the German EUDI wallet project, the project that Christina will talk a little bit more about after me, at Sprint here in Leipzig, the German Federal Agency for Disruptive Innovation. Because digitalization in Germany is disruptive innovation. So in this talk, I'm going to talk about, so I'll give a brief intro on OAuth, OAuth 2.0, we're not talking about earlier versions. I'll talk about the security challenges that anybody who uses OAuth faces. I will talk about the 3 most important recommendations from that security BCP, from that document we've been working on. There are more in there, but I want to talk about 3 so that hopefully you can remember them once you touch OAuth the next time. And then I will tell you why you don't have to remember them, because some people have already done the work for you. You don't have to read the security BCP every single time that you implement OAuth. So let's do a show of hands first. Who in this room has heard of OAuth? And by that I mean OAuth 2.0. Okay, that's almost everybody, great. Who has implemented OAuth stuff themselves? In the most generic sense of the word implemented. Okay, yeah, that's quite a bit. 1/3 or something, maybe 1/4. Okay, great. So for those who are not super familiar with OAuth, OAuth is a standard for federated authorization. So it's all about authorization, meaning that OAuth is the right tool if you want to have an application, for example, a banking app on your phone, access resources of a user, then you can use OAuth to grant this access, to manage this access. This means that then the banking app in OAuth terms becomes a client, and the bank where you access the bank account has an authorization server that creates an access token, and with that access token the client can go to a resource server which has the actual resources, so which knows about the transactions or where it can do a wire transfer or something. We're not talking about the authentication part in this talk because I only have 40 minutes or something. So yeah, authentication you can also do OpenID Connect, right? Which layers on top of OAuth. Also most of the part that Christina will be talking about is more authentication and authorization. But here it's all authentication. And when you think about OAuth, probably you have pictures like these in mind. Stuff where you can do sign in with something. If you have Google Auth applications that can access stuff. Banking, I already talked about that example. Even Apple is doing some kind of OAuth-ish way for the Apple sign and stuff. But that's really just the tip of the iceberg. Because most of the stuff where OAuth is used today is not visible. It's hidden in the backend. It's stuff that's happening and you don't even see OAuth. It's being used in stuff like eHealth, open banking, open finance, open consumer data, for example, in Australia, in digital identity ecosystems. It's everywhere. So it's really everywhere. And when you look at the standards in those areas, most of them use OAuth in one form or the other. And that what you see, like that is really a tiny part of that where OAuth is used. Okay, let's get a bit more technical. Now I will show some nice charts with requests and responses. I hope this is the right audience to not scare away with this. When you look at the OAuth RFC6749, the first thing that you might want to implement is something called the implicit grant. This is OAuth in its most simple form. So you have the user that says, I want to connect my banking app with my bank. Then the client, the banking app, says, that's nice, but I need an access token to do that. Please go to the authorization server with this request. And then that's exactly what the client does. So usually it's just an HTTP redirect. So the authorization request is then sent from the user's browser, usually to the bank, to the authorization server. It contains a bunch of stuff like a redirect UI, which tells you where the response should be delivered, a couple of other parameters identifying the client, and so on. Then the bank will check that you're actually logged in, that you're authenticated. Will also ask you whether you want to give that banking app access to your account, so authorization. And then it will create the authorization response, which takes that redirect UI and attaches a bunch of stuff. Most importantly, it attaches the access token. The access token is the holy grail. With the access token, you can access the resources. Usually it's a bearer token, so whoever has it can access the resources. So whoever has that access token can access your bank account, which is great if somebody is able to steal it, because then they are the bearer of the token and they can use it. So this holy grail really needs to be protected. And this is why there's also another flow in OAuth, which is called, so the access token can then be used to access various resources, right? It can be used directly from your browser if you have a single page application where everything is in the browser, or it can be sent to the backend and then the backend can use the access token. So there's another flow, which is called the authorization code grant. You can see that it works similar. The first three requests, they are essentially the same. You send the authorization request to the bank, user authenticates, authorizes access. But the authorization response looks differently, because there's now the redirect UI and the code, the authorization code. And the authorization code is not the access token. It's like a single-use, one-time replacement for the access token that is returned in the redirect UI, and then the browser forwards that to the backend of your application, of the client's application. And the client can now go, take that authorization code and exchange it in the so-called token request for an access token, which is nice because the access token now never leaves the backend. So it doesn't go through the browser. And I don't have to tell this audience what it means when you have sensitive data in a browser. So this is great. This protects the access token. Is this the end of the story? Obviously not. This is already, all of this is in the original RFC. But this is not sufficient. We see a lot of security challenges in the wild, or when people use OAuth in the wild. The first one is implementation flaws. There are a couple of mistakes you can make, and they happen all the time including a couple of known anti-patterns that are still being used, like insufficient checks for the redirect URI to ensure that the token is going where it is supposed to go. There's a parameter called state, which can protect against CSRF attacks, but oftentimes it's not used correctly. And we've also noticed that client implementations, there are many more client implementations than there are authorization and resource servers, but the clients have a much poorer quality than the servers have, because the servers are often more complex. They are maintained by big corporations oftentimes. Oftentimes they are fine, but the clients do the mistakes. Yeah, there's also research supporting all those findings, so it's really bad on the implementation quality front. But also, since OAuth was first designed, the environment has changed. It's now being used for high-stakes applications like open banking, where you can access your account data and even do wire transfer payments. E-health, so super sensitive health data is now suddenly accessible via OAuth. So maybe we need a second layer of defense because we don't want to have our tokens floating around in attackers' databases. So yeah, e-signing. You can do legally binding digital signatures for, say, a contract over 100,000 euros with OAuth-based mechanisms. Obviously, there's a lot of interest in hacking those. So yeah, and as Christina will tell you, the EU has said we all now need a digital identity wallet. And that needs to support identification on a level of assurance high, so also really high requirements on the security of that. So yeah, is OAuth suitable for that? I mean, it brings all the things we need, but probably you need to really, really make sure that it is secure. So this is all far beyond the scope of the original security threat model. And then we have another challenge, which is that originally OAuth was thought like this. You have a client that accesses, say, 1 or 2 or 3 OAuth providers, each with one authorization server and maybe many resource servers. So a really simple model. And that works fine, but nowadays it's not like this. It's more like this. So you have one client that accesses a bunch of OAuth providers at the same time. And when I say a bunch, I mean hundreds or thousands. So obviously you don't know all of them ahead of time. You don't really trust all of them ahead of time. For example, in an open banking ecosystem, we have like 5,000 banks in Europe. They all have to provide an OAuth interface. So when you have a client that does that, it cannot trust that none of these 5,000 servers is hacked or compromised in some way. And if one of the servers is hacked, I mean, obviously that server now has a problem, but it should not be able to launch attacks on other elements in the ecosystem, which is, for example, what we see in the AES mix-up attack, where one compromised server can get a token from another one that is not compromised yet, and thereby undermine the security of the whole ecosystem. Yeah, so lots of challenges. What can we do? Well, we as spec writers, we cannot go and check every implementation out there. But what we can do is we can write a document and say, look, this is really what you need to do. This is how you secure your OAuth implementation. And that's what we did with the OAuth 2.0 security best current practice RFC. We provide new security guidance. We complement the existing security guidance that we already have in various of the older RFCs. We now also have an updated, more comprehensive threat model, describe all the attacks and mitigations that we know. So this is really the condensed knowledge of the OAuth community on attacks around OAuth. Yeah, so if you want to integrate OAuth attacks into your juice shop, this is the document to go and read and implement all the attacks. Yeah. So what are the recommendations in that document? I would probably need like 3 hours to talk about them all, but here are the 3 most important ones. The first one is please do not use the OAuth implicit grant any longer. There's really no good reason to use it these days. It's just too flawed. It's just too easy to get an access token and misuse it. The access token is sent through the browser, and then various things can happen, like cross-site scripting. It can be read from the browser history. There can be intercepting proxies on various machines that log requests and that maybe don't expect, or log URLs, maybe don't expect sensitive stuff to show up in URLs because it normally shouldn't. There are operating systems that sometimes lock URLs. There are antivirus products that send URLs to some strange servers in other countries. So don't do that. Don't encode access tokens in the URL. Also, it can be replayed. So if somebody was able to steal the access token in some other way, nothing's keeping them from reusing that access token. So for example, if one resource server is compromised, it can turn around and access the resources on all the other resource servers. And finally, there's a threat called access token injection, where you send an access token to the backend that is not the user's access token. So an attacker is able to convince the backend of a user that that backend should now use the access token of the attacker, which means that anything the user does doesn't happen in their own profile, but in the attacker's profile, which can lead to various problems depending on your exact application. So, but the point is, don't use the implicit grant any longer. For all these reasons I already explained. Question is, why is it even in the original RFC? Why is it? So, I mean, it's never been super secure. Why is it even in there? The reason is that originally in 2012, there was no such thing as cross-origin resource sharing. So if you had a single-page application, you didn't have any other option than using the implicit grant. The world has changed. It's 2024. We have ways to use OAuth in single-page applications, even with the authorization code grant. So that's the recommendations that we have. Clients should not use the implicit grant and should instead use the authorization code grant. This is this one, which I already explained before, but you should use some add-ons to it. There are two RFCs that help you with that. The one is for PXE, 7636, and the other one is DPOP or MTLS. They add small building blocks to OAuth that help secure the OAuth flow even more. So the first one is PXE, or Proof Key for Code Exchange. It's a super simple mechanism. The idea is that the client in the authorization request sends a code challenge, which is just a SHA-256 hash of a random number. And then, and only the client can know the random number, right? So you took the SHA-256 hash of it. And then in the token request, the client has to provide the code verifier, which is the original random number. So the client has to prove that it was the client who created the authorization request in the first place. That means that the client essentially ensures that even if somebody steals the authorization code, nobody can use it, because they would not use that random number that the client came up with in the beginning. So that's really useful. And it turns out that it is even more useful than initially anticipated. So if you look at the RFC, it says, yeah, use that for the implicit, for mobile applications and so on, public applications. But it's really useful for every single authorization code grant. You should use it. Then the authorization code should be made single use. It used to be like a vague recommendation, but now it's more strict in a new recommendation. Make it single use. It can only be used once. If you try to use it twice, then all the access tokens associated with it should be revoked. And finally, ensure that you have sender constraining for your access token. What does that mean? I said before that the access token is a bearer token. Whoever has it can use it. This is not ideal. So you should have sender constraining. That is, there should be a mechanism to ensure that only one entity can use the access token. And there are two mechanisms to do that. The one is mutual TLS, which means that the client has to present a certificate along with using the access token. This doesn't have to be like a PKI certificate, it can be self-signed. It's enough to present the same certificate twice, essentially. So when you're getting the access token and when you're using the access token, you have to present the same certificate again. This means that without knowledge of the private key belonging to that certificate, nobody can misuse your access token. And DPOP implements a similar mechanism, but on the application layer. You don't have to play around with certificates and so on and your network stack. It's all happening in headers, essentially added to the request. It's relatively simple to implement. And yeah, it's a very good addition, really secures the access tokens. If you do that, if you use the authorization code grant with PXE and DPOP or mutual TLS, what you get is code and token replay protection and injection protection. Nobody can force you to use their access token. You have sender constraining of access tokens. You even have a CSF protection, because it turns out that PXE is providing a good CSF protection that is better than the original use parameter state is. And it provides defense in depth, because if you do all these things, essentially you have 2 layers of protection throughout your OAuth flow. Even if somebody steals the token, they cannot use it. Even if somebody steals the authorization code, they cannot use it. Yeah. So that's the most important recommendation. Don't use OAuth these days without these things. Then, what else? Well, your redirects. You should enforce that your redirects only, so as a server, redirects only go where they belong. It turns out it's extremely hard to define a pattern for redirect URIs that are safe. You know, *example.com. It looks easy on paper, but in practice it is not. What is your exact syntax? Is it regular expressions? Is it not? What does it mean? Are there any hidden exceptions that the server supports and so on? It turns out that all of this kind of wildcard matching, like almost all of it, is broken in some way or the other. So don't do it. The BCP says use exact redirect URI matching. If your client has to register one redirect URI and you do an exact match on that. Anything other than that is not allowed. And as a client, ensure that you don't have open redirectors because they can really screw your OAuth flow. This stuff is why we need 2 layers of protection, right? Because if you have one of those things wrong, then your token still can leak. And yeah, a second layer of defense ensures that nothing is broken. And finally, ensure that your access tokens are not as powerful as just giving access to everybody and everything. So sender constraining, we already had that. Ensure that it can only be used with the knowledge of a private key. But you should also use receiver constraining. There's no reason, if you have multiple resource servers, to create access tokens that give access to all the resource servers. It's often sufficient to give access to one resource server and one resource on that server, and try to reduce their scope. So maybe for the banking application, reading your transaction data is fine, but maybe you don't need to make a payment with that same access token. Yeah. So as I already said, there's more. There's not only 3 recommendations. If you don't find the time to read the whole 60+ pages document, please at least read section 2, which is the main section for developers and implementers, which really lists all the best practices in a very concise manner. And if you want to know more, then you can look into the attacks section where we define or show all the attacks. Now, you might be confused. I talked a lot about OAuth and its insecurities. And the question might arise, should I even use OAuth when it's so insecure? Well, I would say yes. Yes, absolutely. First of all, standards are good. Ideally, you will not even be implementing OAuth yourself. Please use a good library. Please use a good implementation. If it's even if it's not open source, right? Use something that other people have written and that other people have tested and other people that follow all those recommendations and so on. There are a lot of crappy implementations as well out there, so please use a good one. Then you get battle-proven libraries that other people have tested for you. You also get interoperability because you can use all those features and your server suddenly understands all those features even if you don't have implemented them yourself. For OAuth, we have years of experience. We know exactly what can go wrong and how to protect against it. This is why we have this document. If you implement your own authorization system, you are prone to making the same mistakes because none of those mistakes are obvious when you do this for the first time. So, yeah, please don't come up with your own authorization server and system and protocol. If you follow the recommendations, you get a very good protection even against very strong attackers. We can show that. So we have security proofs, we have security analysis, we have years of experience with that. You can protect even high-stakes APIs, high-security applications with OAuth. You just need to do it in the right way. And we know what the right way is. So, yeah. If you do that, if you touch OAuth, you should, in any case, know your threat model, know what can happen with OAuth, read the security advice, the document that I showed you, including, in the latest version, essentially, and implement those security features and don't say, yeah, probably I don't need them for my application. It's just low-stakes stuff. You might need it. But I also promised you to tell you why you don't need to remember all of these recommendations, right? That is because there's a shortcut. There are specifications called OAuth 2.1 and FAPI2. And they give you a shortcut towards a more secure OAuth implementation. In general, what you'll usually find when you implement any OAuth system of a large enough size is that you need a couple of building blocks. This is an example from open banking, but it applies really to many ecosystems. So we talked about authorization, which you will always need when you do auth, you probably need the authorization part. You might also be doing authentication, OpenID Connect, for example. And the nice thing is that OpenID Connect comes with something that is called conformance tests. This is a test by the OpenID Foundation that you can do with your implementation, with your library, online. And it checks your implementation for interoperability and security problems, which is extremely useful because this takes your library from being a single-use library to one that is really interoperable with other things, that's really following the standard, and that's not publishing your private keys in a publicly accessible URL. This is stuff that the conformance test has found. So that's OpenID Connect, OpenID Foundation. They really have this great conformance test. You should be using it. But as you can see, it doesn't cover any of the OAuth stuff. That's not great. It's just focused on the OpenID thing. And also, we talked about, this whole talk was about security and hardening. And obviously, OAuth 2 doesn't give you that. So what do? Well, you can take a look at the ITF OAuth 2.1 draft. It's a draft. It's not a final specification yet. But that's essentially OAuth 2 minus the insecure options, plus all the recommendations from the security BCP. Also, the document is restructured. Some of it is written with the knowledge that we have today and not the knowledge we used to have back then when OAuth 2.0 was written. So OAuth 2.1 is a great way to get a more secure implementation of OAuth. And So maybe you don't even need to read the original OAuth draft anymore, but read the OAuth 2.1 thing. Now, one piece is missing in large ecosystems. You need to ensure interoperability. OAuth has a lot of options. You can use various methods for client authentication. There are various security features you can use or want to use or maybe not use. So it's a mess. It even says so in the initial paragraph in the RFC that this specification is like a framework for protocols. It's not one single protocol, and that it will lead to non-interoperable implementations because it covers so much. So you want something that is also interoperable, so that the library of one vendor can operate with the server of another vendor and uses roughly the same options. And that's where OpenID FAPI comes into play. FAPI is a profile of OAuth. And this profile covers the interoperability part, the security part, covers all the recommendations we have in the security BCP. There are conformance tests. You can use OpenID Connect with it. And it's even a little bit more secure than what you find in OAuth 2.1. This might be the slide you want to take a picture of. Some people told me that this really clarified the standardization space for them. So there's that. So OpenID FAPI is a great thing because it covers all these things and it boils down all the many options that we have in OAuth to just a few. There are like 4 options in OAuth, in FAPI 2. You might be wondering what FAPI stands for. Well, it used to stand for Financial API, but then it turns out it's not an API. It doesn't define an API. Maybe it wanted to in the beginning, but it's really the Financial API security profile. That's why the name was changed accordingly. Then it turns out, well, there's nothing financial about it. So the goal was to have something that is secure enough for banks, but it doesn't mean you cannot use that for your insurance or anything else, really. There's nothing financial about it. So it was renamed to Financial Grade API Security Profile, just to keep the original FAPI acronym right. But still people came to the OpenID Foundation and were like, this is called Financial Grade. Can I use it for eHealth? We were like, yes, it's called Financial Grade. And so that was really hard to communicate, so we just renamed it to FAPI. It's just FAPI, right? Don't mention the other names. Yeah, so it's a security, interoperability, and feature profile for OAuth 2. Implements all the security recommendation, and this is really, it's like the cheat sheet for what you should do with OAuth. It's really short, tells you exactly use this option, or this option, and nothing else. Usable for all APIs, nothing financial about it, including very high security applications. FAPI 2 is the latest version, soon to be released as a final. Yeah, and that's essentially all I have to say. And if you want to read up on FAPI and the other stuff, you can scan the left QR code. I'd also like to invite you, if you'd like to talk more about this stuff, to the OAuth security workshop, which we'll have in February in Reykjavik, where those people writing the standards and those people using the standards come together to talk about stuff. It's also a non-profit organization. Yeah, and I know it's hard to scan the right QR code when there are 2 on the same slide. Sorry for that. Thank you very much.
Thank you so much. We do have time for some questions. If you would be so kind and queue up here or there in front of the stage, if you have questions. All right. Looks like excellent.
What's the status of OAuth in the juice shop?
We actually have OAuth challenges. I haven't done them in a while. I think they resolve around the implicit grant. We also had a pull request recently to add new OAuth or at a new OAuth challenge, and we weren't sure about it. So if you have time later, I would like to discuss it with you. But yeah, we already have OAuth challenge, but we would like to get your input on maybe how to make them better.
Happy to do that.
So just to give you one question so that you don't go away without a question. Now, you mentioned on one of these slides that there's a formal proof or formal validation. Did you do model checking or something else to prove the protocol?
So there's been a bunch of work on that, both using model checking and other methods. Personally, so my PhD was on exactly this, essentially. And it is a formal model that is essentially a pen and paper model, so it's a symbolic pen and paper model, which is suited to describing web protocols in general, and then we used it for OAuth as well. We first started using it for other protocols, and people kept asking at conferences, have you taken a look at OAuth yet? And we were like, no, there are like 60 research papers out there. We won't find any attacks on OAuth. Turns out we will find attacks. So yeah, and so that's called the web infrastructure model. And based on that, there have been analysis of FAPI and other things as well in that space. So it's a bunch of research at this point.